Good morning everyone. My name is Abhay Chandra, roll number 23B0313, and this is my submission for project ID 1172048 with DP reinforcement learning. So what is the problem statement? We are all aware of the game 2048 where we have to merge tiles and get the maximum score. But this game, although seems very easy, it's very hard to master. Even I haven't reached 2048 till now. So one of my motivation for taking up this project was to sort of take revenge कि I will reach 2048. If I can't do it, I can train a model, reinforcement learning model to do it. So this was the problem statement to play 2048 with reinforcement learning. Now, according to the proposed solution. So, my solution to this is to use reinforcement learning. As we know, the reason 2048 is difficult to play with machine learning because it is a random game. It is a stochastic event. We don't know where, like, if we swipe, where the next tile would be. If the next tile position would be known, it would be quite an easy game, and even machine learning would not be required to solve this game. But as you can see, the new tile position is random, so we need reinforcement learning to do this. So this is my midterms report. As you can see, we go over concepts like Bellman equation, temporal difference learning, the state action value functions, the discount term, the Q values, and how you can train the Q value table, the lookup table. As you can see, this is a rough example of a lookup table. And the main idea is temporal difference learning. Like, how do you train the network? See, you can see the new Q value is based on the older Q value plus alpha, which is the learning rate, times in bracket the reward. Reward is the, like, what reward do you get on going to the new state, plus max of Q value of the future state minus the current state. Now, why we are choosing max? Max means pick that action which for which the Q value is maximum. So what is the concept of reinforcement learning? Reinforcement learning is that we place an unclueless agent in an environment. An agent, based on the rewards it receives, tries to figure out the best possible policy to get the maximum rewards. Its main aim is to maximize the rewards. So now let's talk about what is the paper, like how do you apply reinforcement learning to 2048 game. Now, as you can see, our objective is कि we implement temporal difference learning methods to get a nice policy for in an environment, and the main thing that we use is n-tuple networks, which, because let's see, you can normally the hard way is to get all the possible states and you can feed in that, but 2048 game has so many states. See, this is the major point. You can use the Q table lookup and you can use make all possible states that 2048 game can have and have a corresponding Q value. But in the game of 2048 there are many states. There are over 4 into 4 to the power of 18 states, and this is a lot to keep a track of. So to counter this, we use a function approximator that adopts a class of parameterized function to replace the value table, and that is the n-tuple network that consists of m, ni tuples, where ni is the tuple size, and it calculates the sum of values returned by individual n tuples. Now let's go over the code for which I'll go over to this. So first we have, all in all, we have the 4 major files, that is agent, demo, game and main. So the game.py files defines the game environment in which the agent plays. So here is the up, down, right, left. We assign each action with a number. Here is the compress, which removes 0, and this is the main merge. Like the argument is the row, and its aim is to return and reward after merging that row, and what is the final row after merging. So you can see, and this starts from left end, meaning this merge is for swiping left. Like what if you swipe right, this function will give you an output of that. So you can read the comments, and the code is very descriptive, and at each point I have tried to give comments to describe what is happening. Now this class is the board. Now notice our board is a list of 16 integer, and the main thing to keep in mind is these integers are the value 16. Why 16? Because 2048 is a grid of 4x4, and we represent each element by power of 2. Like what is the power? Like in actual board, if it is 2, we'll represent in our list as 1, and if it is 4, we'll represent it as 2. So this def empty tiles returns a list of empty tiles you can get by itself, and this spawn tile is responsible for the random element of the game for spawning a new tile. This is for displaying the board, and this is for the action. This is also very good, important part. Like what to do if your action is left, what if you swipe left. So this is this, and this, please read this comment, this is very important. And this describes what happens if we do right, up, down and left. Now this is merge to left. This utilizes the merge statement that we wrote before. Now coming to the agent.py, that is the reinforcement learning part of our project. Here we define the n tuple networks. This LUTS stands for lookup tables, and this is for tuple ID. We define unique index given to tuple of tile values. This index is used to access from the lookup table. And here is the value function, the main part. Like how do you decide how good is a action in a given state? This value function returns a value. And also, what does this delta mean? Delta is for learning. Like if delta is given, then it is used to update the lookup table, hence facilitate learning. This evaluate is for the total reward for performing an action A. And this best action, as you can see, this statement, this returns, like this checks, like do up, do right, do down, do left, and which action results in the best reward. This function will give you that action. And this is the main part of the learning process. Like this will go over each. You can see R next, S next is the state after performing the action. And what does this after next means? In 2048 there are like there is a initial state, there is a transition state, and there is a after stage. This after next stage is for that. Transition state is where the new tile randomly is added. So this is used to print like if debug is on. Debug is for personal facilitation, where what happens if we want to debug. Now coming to main.py is where we play, like the main playing. This utilizes both game.py and agent.py and uses it to play the game. And here we define the tuples that we use, the horizontal, vertical and all 4 tile tuples. And this is the training aspect. Here you can see like how what to do when training interrupted, and how training is happening. And this demo.file is like to final game, like when demo happens. So that's it. Thank you so much.